Hello, electrical engineers. Today, we are going to do something really cool. We'll run a power flow analysis in DIgSILENT PowerFactory using the classic IEEE 9-bus system. Alright, before we jump in, let's quickly understand what this system actually is. So basically, the IEEE 9-bus system is a small test power network with 9 buses, 3 generators, 3 loads, and a bunch of transmission line connecting everything. Here you can see the simulation environment of the DIgSILENT PowerFactory. So I have drafted the IEEE 9-bus system in our simulation environment, and you can see there are 9 buses: 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 buses, that's why it is called the IEEE 9-bus system. And there are 3 transformers, and actually there should be 3 generators, but for our convenience I have added some more generators, like 1 synchronous machines here, and 1 battery here, and 1 external grid to see the load more apparently. And there are 4 loads, like 1, 2, 3, and 4. So to see the load flow analysis, so we'll have to click this icon. You see the calculate load flow, or Control plus F10. Alternatively, you can click the calculation tab and you see load flow, and then this window will pop up, and you see there are 3 different options. One is AC load flow balanced, positive sequence, AC load flow unbalanced, 3-phase ABC, and DC load flow. So for our calculations for now, we will consider AC load flow balanced positive sequence, and then click execute, and then you see that the load is flowing throughout the network. If you hover over your mouse on any particular bus bar, then you can see there are some values of some parameters, like the voltage, then per unit voltage, the angle, and the nominal current. And if you want to see the whole, the values all together, then you can click the network model manager, and then click here the bus bar, and you can see that all your 9 buses are here: 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see the nominal voltages, and then there are some voltage drops, different bus bars. Here's the magnitudes, and here's the per unit magnitudes, and then angle, and then apparent power here. And similarly, you can see the value of the static generators, apparent power degrees, and then reactive power, and then the true power. And here is the general load, and then external grid load, and the synchronous machine. So this is how we can perform the load flow. So you can see that some of the equipments are turned red because it says that it's overloaded. Okay? Like if you overrun on this equipment, it is a 96.7% loading, which is excessive. So how we can fix it? If you double click and the type, and you go through this, you see the rating of the transformer rated is 100 MVA, which is not sufficient for our load. So if you increase the rated power of the transformer 100 to 130, and then click OK, and then OK, and then you execute the load flow, then you see it fixed. it's no longer be read anymore. Similarly, you can fix the rest of them. This is how we can perform the load flow. I hope you have learned something from this lesson. Thank you so much.